Now that we're confident in calculating wind and temperature data, we can now apply it to the first phase of our flight, climbing. For this, the climb data is available on pages 2-8 to 2-10 of the Boeing 727 handbook. Looking at the top of the pages, we can see the data presented is for 3 ISA deviations. We have ISA, ISA plus 10, and ISA plus 20. It's important to note that the ISA deviation to be used is the nearest 5 degrees. This will mean we have to quite often interpolate between the pages. For example, if the ISA deviation was ISA plus 3, we'd have to interpolate for ISA plus 5. If the ISA deviation was ISA plus 14, we'd interpolate for ISA plus 15. So that would mean interpolating between ISA plus 10 and the ISA plus 20 tables. Another factor to consider in the climb chart is the fact that the aircraft weights are presented 4,000 kilos apart. The brakes release weight we enter has to be to the nearest 2,000 kilos, so you'd quite often be interpolating for the weights as well as the ISA deviations. Let's look at an example. The brakes release weight was 82,000 kilos and the ISA deviation was ISA plus 5. Then we'd have to interpolate between 80,000 and 84,000 to get 82 tonne data. We'd also have to interpolate between ISA and ISA plus 10 tables to get ISA plus 5 data. So this would lead to a 4-way interpolation. Let's consider one block of information from page 2-8. Departing from an aerodrome in ISA conditions and climb to floor 330 with a brakes release weight of 76 tonne, we can see the following data. Looking at the second column on the left hand side, the unit representations can be found. They are time, fuel, distance, and true airspeed. In our example, the following values are found. We're climbing for 21 minutes, we're using 2,800 kilos of fuel, and we're travelling 130 air nautical miles. We've also got an average TAS written in here as 414 knots. This isn't to be used in the exam, so you can just ignore that section. The time in the climb and the fuel consumed are pretty straightforward variables, and the nautical air miles is the distance flown in nil wind conditions. To convert from air nautical miles to ground nautical miles, we have to apply the relevant head or tailwind component. In order to work out a tailwind component to convert from nil wind distance to ground distance, we need a TAS to see if there's any ETAS corrections to be done. Rather than calculating a TAS, you can just use a nice round number of 400 knots for ETAS calculations when you're conducting the climb segment. Once you have a wind component, we can use the formula written here to find the effect that the wind has had on the distance covered. In our example, we're climbing for 21 minutes. Let's pretend we had a wind component of minus 40, so that's a 40 knot headwind component. Now the formula here can also be written as time divided by 60 multiplied by the wind component. So don't stress too much if you can't remember which variable goes where. So for this scenario, we have 40 knots divided by 60 multiplied by 21 minutes. That gives us 14 nautical miles. So we have to adjust our nil wind distance by 14 miles to get ground distance. We've either got to add it or subtract it depending if it's a head or a tailwind component. In this case, it's a headwind component, so we'd reduce the distance covered by 14 miles. That would give us a ground nautical mile coverage of 116 miles rather than nil wind conditions of 130. This is the quickest and easiest way to calculate ground nautical miles, and it's going to work for both climb and descent data. To summarise the climb segment we've just done, we've climbed for 21 minutes, we've burnt 2,800 kilos of fuel, and we've covered 116 nautical miles over the ground. Before we cover some more examples in the next video, we have to discuss what route sector winds and temps to use for each climb. As the climb performance of an aircraft slows as it gets nearer to its top of climb position, CASA has told us we should use a route sector wind and temp that is closest to the 2/3 point in our climb. To make it easy for you, we have the following rules. If you're climbing up to and including flight level 310, we'd use the data from the 185 route sector wind and temp. If we're climbing to 330 or above, we'd use a 235 route sector wind and temps. In the next video, we'll go over a couple more examples together. This will include picking the wind and temperature data ourselves.